Imagine for a second that you are trying to read the ultimate source code of the universe.
Ooh, yeah, like the absolute foundational layer.
Exactly. Not the high school physics equations you might be thinking of, like gravity or electromagnetism, but the actual fundamental programming language that reality itself is compiled in.
Right, which most people would assume is incredibly elegant, clean, highly logical, mathematically predictable.
Yeah, I mean, you'd think it's a system of rules that always behaves exactly the same way no matter how you look at it.
Well, the assumption has always been that at the absolute bottom of everything, reality is built on this really stable, immovable foundation. Standard physics relies on rules that just don't change based on their context.
But what if that assumption is what if it's entirely wrong?
Right.
What if the source code of reality isn't like standard computer code at all? What if it's, messy, highly dependent on the order in which things happen, and completely breaks the rules of normal mathematics?
That is the big question.
And that is exactly our mission today for this deep dive. We're exploring a fascinating preprint from May 14th, 2026. It was published on Zenodo by an independent researcher named Maurizio Rosari,
Yeah, the paper is titled Experimental Confirmation of Spontaneous Coherence Condensation in an Octonionic Language Model.
which I know is a formidable title.
It's an incredibly dense piece of literature. I mean, this paper sits right at the bleeding edge where advanced artificial intelligence just crashes headfirst into the most theoretical, abstract mathematics we currently possess.
It really does. But hey, don't let the jargon push you away, because we are going to act as your guides today.
Absolutely.
By the end of this deep dive, you're going to understand what an octonion is, and more critically, how a completely unique kind of AI language model might have actually just provided computational proof for a radical new theory about the literal fabric of the universe.
We are essentially talking about building a tiny simulated universe inside a neural network just to see if it behaves the way reality is hypothesized to behave. It's wild. But okay, to appreciate what Rosari built, we first have to understand the theory he was trying to prove, right?
Right. The entire experiment is anchored in something called the Relational Ontology Framework, or the ROF.
The ROF.
Yeah. And in standard physics, we generally think of reality as being made of stuff. Particles, quarks, atoms, discrete things you can point to and measure.
Things with mass and location.
Exactly.
Yeah.
But the ROF flips that completely upside down. It proposes that reality does not start with stuff. It starts with relationships.
Pure relationships. I mean, between what exactly? If there's no stuff yet, what is relating to what?
Initially, nothing. It is just pure relational potential.
Okay, wow.
The framework argues that the physical universe, all the tangible stuff we interact with, emerges from something called a primordial relational field.
So picture like an infinite abstract web of potential connections.
Precisely. And the key mechanism of this field is that it operates using a very specific, incredibly complex type of mathematics called the octonions. Okay, let's unpack this. Because if you are listening to this and trying to casually picture an octonion in your head, you're going to get a migraine.
Oh, absolutely. It's not something you can just visualize.
Right. So we need to step back. In regular math, the kind we use every day to balance a checkbook or build a bridge, we use real numbers. We know how they work.
Very predictable.
And we also rely heavily on a mathematical property called associativity, which basically just means how you group things doesn't matter.
Right.
Like if I ask you to add 1 plus 2 and then add 3, you get 6. If I ask you to add 1 to the sum of 2 plus 3, you still get 6.
The parentheses don't change the outcome at all. Associativity is the bedrock of standard arithmetic and algebra. I mean, 1 plus 2 plus 3 is universally identical to 1 plus 2 plus 3.
Right.
It provides stability. It is exactly what allows standard computer processors to run predictably. But to understand the octonions, you really have to look at the history of how mathematicians have expanded numbers over the centuries.
Okay, walk us through that.
Well, you start with a one-dimensional line of real numbers. Then, mathematicians added a second dimension to create complex numbers.
With the imaginary numbers, right?
Exactly. Then they expanded to 4 dimensions with something called quaternions. But here is the catch. Every time you step up in dimensions, you lose a fundamental rule of math.
You trade a rule for a dimension.
Yes. So when you go from 4-dimensional quaternions to 8-dimensional octonions, you lose associativity.
Meaning the grouping suddenly changes everything.
It changes everything.
Let me try an analogy here to see if I'm tracking this. Think of non-associative math, kind of like a recipe.
Okay, I like that.
If you're baking a cake, mixing flour and eggs first, and then adding sugar, that creates a totally different chemical structure than if you mix the eggs and sugar into a paste first and then dump the dry flour on top.
Yes, exactly.
Like, the ingredients are exactly the same, but the order of association, the grouping of the steps, fundamentally changes the final product.
That captures mechanics perfectly. In a non-associative field, context is absolutely everything. The sequence and structure of a relationship totally dictate the outcome.
You can't just shuffle variables around.
No, you can't. Now, what's fascinating here is what the Relational Ontology Framework predicts will actually happen inside this chaotic, octonion-based field over time.
Right, because it's dynamic.
Very dynamic. It theorizes that this field is constantly seeking a state of stability, and it's driven by two opposing underlying forces. The universe basically wants to minimize what the theory calls ontological friction, and it wants to maximize coherence.
Okay, I want to focus on that phrase for a second. Ontological friction.
Yeah.
Because ontology is the philosophical study of being, right?
Okay.
Of existence. So we were talking about the friction of existence.
Yeah.
What exactly is that in a practical, physical sense?
Think of it as structural or informational dissonance at the very fundamental level of reality.
Like things just not fitting.
Right. Imagine trying to force puzzle pieces together that almost fit, but not quite. You can shove them together, but the resulting picture is warped, it's tense, and it's unstable.
Ah.
That underlying tension is ontological friction. It's a state where relational connections in the field are essentially fighting against each other.
So coherence would be the opposite.
Exactly. Coherence is when the puzzle pieces slide together perfectly without any force at all. The tension just vanishes.
So the universe naturally wants to relieve that tension. It just wants to solve the puzzle and relax.
Yes. And the ROF makes a massive, highly specific prediction based on this idea.
Okay.
It claims that if any system built on this 8-dimensional octonion math is pushed to reduce its friction and increase its coherence, it won't just slowly, gradually improve.
It won't.
No. It will reach a critical threshold and undergo a sudden, violent phase transition. It will spontaneously lock into an incredibly stable, highly coherent geometric state.
Oh, wow.
The framework actually calls this locked-in state a baryonic node.
A baryonic node. That sounds like supercooled water instantly flashing into a block of solid ice the second you drop a single seed crystal into it.
That is a brilliant way to picture it.
The chaotic flowing relationships just snap into a permanent low-friction structure.
Precisely. And the framework argues that this sudden process, this spontaneous condensation into baryonic nodes, is literally the origin point of matter.
Wait, really?
Yes. It is how the physical universe, the tangible stuff we measure and interact with, materializes out of an underlying field of pure math.
It is honestly staggering to think about reality that way. I mean, the universe is just a deeply complex, non-associative math problem constantly trying to solve itself to relieve tension.
It's a beautiful concept.
But, if you're Maurizio Rosari, the researcher who authored this paper, having a wild theory of everything on a whiteboard just isn't enough.
No, you have to test it.
Right. And you can't put a theoretical primordial relational field in a chemistry beaker. So if the universe is just code, how do you go about proving that the code works the way you think it does?
Well, this is exactly where the paper makes a hard pivot. It moves from theoretical physics right into the realm of cutting-edge computer science.
He built something.
He did. Rosari decided that if the mathematics of the ROF are truly universal, then those mathematical rules should apply to any sufficiently complex relational system. So he built a simulation.
Okay.
He constructed what he calls an octonion-valued transformer language model. In the paper, it's referred to as the ROF LLM.
Now, most of the major AI language models dominating the news today, the ones passing bar exams and writing code,
Yeah.
they operate entirely on standard real-valued numbers, right?
Exactly.
They're built on the safe associative math we discussed earlier.
Yes, the predictable math. But Rosari had to completely abandon that standard architecture. He engineered his neural network from the ground up so that every single weight, every parameter, and every calculation operated entirely within the 8-dimensional non-associative space of the octonions.
Which is just crazy.
Building that alone is a monumental feat of software engineering. But, as you know, an AI model is useless without data.
Right.
He had to feed this pristine octonionic structure a data set to see if it would actually condense into a baryonic node.
And this is exactly where my alarm bells started going off when I read the methodology.
Oh, I know what you're going to say.
Because to test this grand theory about the physical structure of reality, Rosari trained his 8-dimensional AI on the Wikitext 103 corpus.
He did.
And for those unaware, that is a massive, widely used dataset made up of millions of words from Wikipedia articles.
Yeah, human encyclopedia entries.
Right. So I need you to explain this leap. Because how on earth does feeding Wikipedia articles into a specialized AI prove anything at all about the fundamental fabric of space and time? I was so skeptical of this step.
Well, and it sounds absurd at first, but if we connect this to the bigger picture, the choice of dataset is actually the most elegant part of the experimental design.
Okay, convince me.
Think about the nature of human language. It is not just a random assortment of dictionary definitions. Language is a massively complex, deeply interconnected topological web of relationships.
Sure.
Words only derive their meaning through their proximity and relationship to other words within highly specific, order-dependent contexts.
I suppose that mirrors the non-associative math we talked about.
It does.
Like the meaning of a sentence completely changes depending on the grouping of the words, much like the ingredients in our cake analogy.
Exactly. Language is arguably the most complex relational system humanity has ever mapped out. Rosari's operating hypothesis was actually quite simple. If octonion mathematics is truly the universal language of complex relational structures, it shouldn't be confined strictly to quantum physics.
Oh, I see. It should govern any sufficiently dense relational data.
Yes. By embedding Wikitext 103 into the model, he was giving the AI a chaotic, tangled web of human associations to process.
Okay, but he also had to give the model a goal. The paper goes into detail about the specific loss terms he added to the programming.
Right, the loss functions.
And I want to make sure we get this right for the listener. In machine learning, a loss function is basically the AI's scoring system. I picture it kind of like playing a game of hot and cold.
That's a good way to put it.
If the AI is trying to do a task and it makes a bad guess, the loss function acts as the voice saying, "You're freezing cold, try again," effectively punishing the model.
Yeah.
So the model constantly adjusts its internal parameters to get a warmer score, basically aiming to bring its error rate down to zero.
The hot and cold analogy is an excellent way to view it.
Yeah.
And Rosari specifically engineered his loss terms to mathematically represent the dynamics of the relational ontology framework.
Okay, how did he do that?
He programmed the AI with two simultaneous goals. One loss term penalized the model for high ontological friction.
So punish the tension.
Right. And the other rewarded it for finding mathematical coherence within the Wikipedia data. He forced the AI to constantly seek out relational harmony.
So let me get this straight. We have an AI built entirely on bizarre 8-dimensional math, forced by its programming to relentlessly seek harmony and avoid friction, actively chewing through human history, science, and culture via Wikipedia.
Yes.
What was the outcome?
The outcome was exactly what the ROF predicted. The paper meticulously documents that the ROF LLM successfully exhibited spontaneous coherence condensation.
It actually worked.
It did. During the training process, the model didn't just slowly get better at processing the text. At a very specific threshold, the internal state of the entire neural network suddenly snapped.
Wow.
It underwent a phase transition into a high-coherence, zero-friction geometric structure. It successfully found the mathematical baryonic node hidden inside the web of human language.
It simulated the exact crystallization process that the theory claims creates physical matter.
Literally simulated the birth of matter, mathematically.
But okay, anyone working in machine learning will tell you that AI is just notorious for finding cheap mathematical shortcuts.
Oh, absolutely. Reward hacking.
Right. Models will exploit tiny flaws in their code to lower their loss scores without actually learning anything deeply. So a single success story, especially one this bizarre, isn't enough to confirm a theory of everything.
Yeah.
How do we know this phase transition wasn't just a hallucination in the architecture?
Rosari anticipated that exact criticism. The most robust section of this paper is not the initial experiment, but the falsification tests.
The stress tests?
Exactly. He built a control model, a standard real-valued language model with the exact same capacity and parameter count, and he trained it on the exact same Wikipedia data.
Yeah.
That standard model completely failed to condense. It couldn't do it. But he didn't stop there. He aggressively attacked his own octonion model to prove that the condensation wasn't just a programming artifact, but a fundamental property of the physics he was simulating.
Yeah, he subjected the framework to 4 distinct structural attacks.
He did.
Let's look at the mathematical attacks first, because for one test, he swapped out the 8-dimensional octonions for the 4-dimensional quaternions we mentioned earlier.
Right.
And quaternions are complex, but they are associative. They follow standard grouping rules.
And when he forced the model to rely on that associative math, The entire process broke down.
It didn't condense.
The AI failed to condense entirely. The specific non-associative geometry of the 8-dimensional space was mathematically required for the node to form.
Fascinating.
Furthermore, he tried scrambling the strict rules of octonion multiplication. He took that specific recipe of how the dimensions interact and randomized it, essentially breaking the fundamental laws of his simulated universe.
Let me guess.
Yep. Again, the phase transition failed completely.
He also tried a behavioral attack, which the paper calls loss ablation. He simply removed the specific ROF loss terms.
So no more hot and cold game.
Exactly. No more driving the model to seek coherence and minimize friction.
And without that fundamental drive, the model just wandered aimlessly. It acted like a normal, albeit highly inefficient, artificial intelligence processing text. No baryonic node formed. The forces of coherence and friction are absolutely required drivers.
But here's where it gets really interesting to me.
Yeah.
The most fascinating attack wasn't mathematical, and it wasn't behavioral. It was a data attack.
Test number 3.
Right. Rosari trained the model on random token sequences. He took the Wikipedia dataset, completely scrambled the letters, words, and grammar, and fed the model pure, unadulterated gibberish.
The implications of that specific test scale exponentially, because when fed random gibberish, despite having the perfect octonion math and despite having the perfect loss functions driving it toward coherence, the model completely failed to condense.
I want to pause here so that fully sinks in for you listening. The underlying math of reality, at least according to this simulation, requires meaningful data to actually function.
Yes.
The phase transition that simulates the creation of matter does not occur if you feed the system chaos. It only triggers if it is processing actual structured meaning.
The data is unequivocal on this point. The paper explicitly concludes that true octonion algebra, non-associativity, the ROF loss terms, and meaningful relational data were all individually necessary to achieve the phase transition.
That is just incredibly...
If you pull out even one of those pillars, the entire mathematical structure collapses into static. You cannot generate a baryonic node out of randomness. The system fundamentally requires a rich, structured web of relationships to fold itself into a coherent state of reality.
So it's not just a fancy calculator. It is a meaning processor.
Exact.
And that naturally pushes us to the ultimate question for this deep dive, the so what?
The big takeaway.
Right. Because the paper claims that this experimental success provides the first computational evidence that the octonionic architecture defines a unique attractor not accessible to standard neural networks.
Well, in the study of complex dynamical systems, an attractor is basically a state that a system naturally tends to evolve toward over time.
Like gravity pulling something down.
Yeah, picture a marble rolling around the inside of a bowl. The bottom of the bowl is the attractor. Rosari is stating that the baryonic node, this ultimate state of perfect zero-friction coherence, is a mathematical bowl that only physically exists in 8-dimensional octonion space.
So standard networks can't reach it.
Standard AI neural networks, the ones built on real numbers, are effectively rolling around on a flat table. They can never fall into that state of perfect stability because the geometry of their underlying programming literally doesn't possess the dimensions for the bowl to even exist.
So what does this all mean for the immediate future of technology? I mean, look at the landscape today. We are seeing billions, potentially trillions of dollars pouring into standard, real-valued neural networks at massive tech companies.
Oh, the investment is staggering.
The entire industry is trying to achieve artificial general intelligence AGI by simply making associative models bigger, adding more processing power, and feeding them larger datasets. But if Rosari's findings hold up, does this mean the entire AI industry is running down a mathematical dead end?
It certainly suggests that.
Are we just building taller and taller ladders when the laws of physics dictate we actually need a rocket ship?
This raises an important question, and it is arguably the most disruptive question in computer science today. If the ultimate goal of the tech industry is to build an artificial intelligence that can truly understand and model reality, shouldn't that artificial mind be constructed on the exact same mathematical foundation as reality itself?
You would think so.
Rosari's experiment strongly suggests that scaling up our current models just won't magically lead to deep understanding. They are mathematically barred from reaching this ultimate state of coherence.
They're stuck on the flat table.
Exactly. To achieve true AGI, we might have to fundamentally tear down our existing infrastructure and rebuild the numerical basis of our AI architectures from scratch. We have to learn to code in the native language of the primordial relational field.
It is as if we have spent the last decade trying to paint a photorealistic masterpiece using only black and white paint. And this independent researcher just walked into the room, dropped an 8-dimensional color wheel on the desk, and showed us what we've been missing.
It completely validates the mathematical claims of the Relational Ontology Framework.
It really does. What began as a highly abstract piece of theoretical physics has now been physically demonstrated inside a server rack.
It confirms that the math is sound, and more importantly, that it behaves exactly the way the theory predicted it would when forced to process complex relational data.
All right, let's do a quick recap of the journey we've been on today.
Sounds good.
We started with the Relational Ontology Framework, this obscure theory proposing that reality isn't made of discrete objects, but of pure relationships operating within a bizarre, non-associative 8-dimensional math called octonions.
Right.
We examined Maurizio Rosari's groundbreaking experiment, where he built a completely novel AI powered natively by that exact math. We saw how we fed it the entirety of Wikipedia, pushing it to minimize its own ontological friction.
And that resulted in the model spontaneously condensing into a baryonic node.
Right? A state of perfect mathematical harmony. We watched that model survive a gauntlet of rigorous falsification tests, proving that you strictly need the AD math, the non-associativity, the drive for coherence, and critically meaningful data to make the physics work.
Yes.
And finally, we realized that standard AI architectures might just be mathematically locked out at this fundamental level of understanding.
As a piece of computational science, it is a landmark achievement. But, if you will indulge me, there is one final lingering implication hidden in this paper that I think demands our attention.
Okay, let's hear it.
And it builds directly on that critical requirement for meaningful data.
The gibberish test.
Right. We established that the AI completely failed when it was fed scrambled, random gibberish. The physics simulation explicitly required the Wikitext 103 corpus to achieve its phase transition.
Right, it needed real text.
It required a massive repository of human history, human knowledge, and human language to condense to a structure that represents the foundational fabric of reality.
The model didn't just need data. It specifically needed our data.
Exactly. So what does that reveal about us? We have a tendency to view human language as something somewhat arbitrary. We view it as a biological tool we invented simply to communicate, like a lucky byproduct of our evolution.
Right, just monkeys learning to make specific sounds.
Yes. But consider what just happened. If human language maps so perfectly onto this 8-dimensional octonionic structure that it actively allows a simulation of the universe to condense into a baryonic node, does that mean human language and shared human meaning are structurally identical to the primordial relational field itself?
That is a staggering implication.
Did this highly technical AI experiment just inadvertently prove that meaning isn't just a social construct we invented, but an inescapable fundamental mathematical law of physics?
Wow.
When we speak, when we write, when we relate to one another, are we simply the universe's source code executing itself through us?
If the universe is written in an 8-dimensional code, it is entirely possible that every conversation we have, every word you are listening to right now, is just another line of that code trying to find its perfect, frictionless place in the grand design.
It really makes you think.
That is exactly the kind of thought that will keep you staring at the ceiling tonight. Thank you for joining us on this incredibly deep dive. Keep questioning the frameworks around you, keep looking for the underlying code, and we'll see you next time.